there, welcome back. We're starting topic 2 today, proportional relationships and tables. We did touch on this in the first topic, but we're really going to dive into what a proportional relationship is in topic 2. We first have our sentence saying that two quantities, x and y, have a proportional relationship if y is always a constant multiple of x. That is a very deceiving sentence. Y is always a constant multiple of x. It means that, like, let's say, for example, if I had 4x and I say that that's equal to y, whatever I put in for x proportionally should be my y. So if I had 4 times 1, that would give me 4. If I had 4 times 2, that would give me 8. If I had 4 times 3, that would give me 12. Proportionally, I see that I just keep going up by 4, up by 4. So the circle and square ratio, we talked about this in a previous topic, that they're showing us the number of circles in red to the number of squares in blue is equivalent to 2 to 1. And that 2 to 1 came from 6 to 3, which they reduced down to 2 to 1. So they're going on and saying that there are 2 times as many circles as squares. There is a proportional relationship then between the number of circles and the number of squares. So let me ask you this. How many squares would there be if there are 12 circles? Just stop and think about that. You should be saying to yourself that if there were 12 circles, if there are twice as many circles as there are squares, then I have to do 12 divided by 2 to get me that there would be 6 squares. Then moving on to what a table is going to look like, it tells us that a table can be used to show a proportional relationship between two quantities. You learned last year that graphs can also do that, which we will be talking about in the future. But we've got our table here, and I want you to notice this ratio y to x. I'm going to write it nice and large over there. The y divided by the x. It's always going to go in that order. I know we're kind of used to thinking alphabetically here, but it's y divided by x. Each of these ratios, y divided by x, is equivalent to 2 to 1. If you look at your table, the x is on the left, the y is on the right. They have 2 to 1 is our original ratio. Then they took and put 4 to 2, 6 to 3, 8 to 4, and reduced them all down to 2 to 1. It goes on to say that each y value is twice the corresponding x value. And you can see that moving along this way, twice, twice, and twice. And again, they're now saying because we can see that, the table shows a proportional relationship between x and y. Example 1 states that the table shows the cost for 4 different photocopying jobs. Is there a proportional relationship between the number of copies and the cost, and how do you know? They are showing us a table here, but instead of writing the x and y for us, they are saying the number of copies to the cost. But I like to just go x and y. 99% of the time, your x is always on the left and your y is on the right. We need to be comparing our ratio of y to x, which will be the cost to the number of copies. And if you look at that, the money is on top, which we just practiced with unit prices. So we're going to go through and actually decide if all of these ratios are equivalent. So our first one will be $18 to 150 copies to give me 12 cents per copy. Then I'll have $27 for 225 copies, which again is 12 cents per copy. So far, it is showing that it is a proportional relationship. Now, if I do $55 for 550 copies, I'm going to get 10 cents. And just to make sure that I didn't do any of my math wrong, I want to see if I did $84 divided by 1,050, it's now 8 cents a copy. So when they asked, is there a proportional relationship? Because these 4 numbers are not all the same, no, the ratios or unit prices are not equivalent. Just like being in school. And I left off a letter there, not equivalent, okay? And you want to make sure that you're really specific about how you say that. And normally, the more you buy, the cheaper they get for a price, and that's what's happening in this chart. I'm going to start number 2, just get you on the right path here. Again, we're going to remind ourselves that our ratio is y to x. That is really the key concept for today. They want us to, again, determine whether each table shows a proportional relationship between x and y. So basically what we just practiced on example number 1, same thing's going to happen here. I just want to show you that it is okay to get fractions. You just have to make sure that all of the fractions are equivalent when they're in simplest form. So if I started with the one on the right, if I have my y divided by x, 4 divided by 8 will give me 1/2. And that's okay, there's the fraction. Nothing says it has to be a whole number. But then my next one is 3 to 7, and I can't reduce 3 7. The next one would be 2 6, which will reduce down to 1/3, and the last one would be 1/5. So that one is absolutely not proportional. Sorry, just got interrupted there. So not proportional, for example 2. On the other side, if I start off by saying 9 to 3, that reduces down to 3 to 1, not 1/3. If I now compare 36 to 12, that's going to reduce down to 3 to 1. And then now we get to the fun part with our fractions. We're still going to put 4/3 to 4/9. Sorry, that keeps disappearing. I'm going to simplify this ratio so that I have only one number in the numerator and one number in the denominator. I'm going to multiply by the LCM. Same thing we practiced in the last topic. The LCM of 9 and 3 is 9. So that will let me cross cancel those. 3 to 1. Then 9 and 9, bye-bye. So I'm left with 4 times 3 to give me 12. And 4, which is 4, which, yay, reduces down to 3 to 1. Then I will let you try the last one on your own. Just remember that if you have a mixed number, you should be converting that to an improper fraction, which will be 4/3 here. So go ahead and do that last one on your own. You probably saw that since the first 3 ratios were 3 to 1, you're probably hoping that the last one would also be 3 to 1. I did it in a different color here, so it's easier for you to see, and it does end up being 3 to 1 as well. Number 3. The way that I am going to show you is not the one and only way to solve this problem, but I just find overall this is the easiest way to present it to you. It says, a company manufactures custom car paints. A manager receives orders for 25, 35, and 105 gallons of powerful purple paint shade. The paint manager panics and says, none of the orders match our mixing chart. So how can we make these orders? Provide a solution for the panicked paint man. Some alliteration for you. So they have given us this chart here, and they are showing us how many gallons of red paint we need and blue paint to make the purple paint. So it's almost like this chart is missing for us to interpret how many gallons total of purple paint we're going to be making. So the total gallons of purple paint in this one, 2 plus 3, would give us that there are 5 gallons that are being produced. The next one would be that there were 10 gallons produced. The next one would be 50 gallons produced. And the last one would be 100 gallons that were produced. The numbers that they are giving us up here is the total. So those numbers, if I was to continue my chart, would go in the purple section of this. Let me just move this up a little bit more. So there were orders for 25, line, 35, line. And now we need to figure out how many gallons of red and blue we're going to need. So again, there are a couple different ways to do this. I'm going to think to myself setting up a proportion. If you use the red paint to blue paint, though, that's not going to be useful if the information they're giving us is the total purple. So the purple paint has to be included when I set up my proportion, because that's one of the pieces of information they gave me. So if I decide to do red to purple, and I just chose red because that was the first one in the chart, I know, looking right here, that if I have 2 gallons of red paint, how many gallons of blue I put in, that's going to give me a total of 5 purple. So if I use 2 to 5, set that equal, I need to figure out how much red paint I need when I'm making 25 gallons of purple. So how do I go from 5 to 25? Multiply by 5. So up here, 2 times 5 would give me 10. So I will need 10 gallons of red paint to get a total of 25 purple. So how many gallons of blue paint do I need? I need 25 minus the 10 gallons of red to get me 15 gallons of blue. So when it says, how can we make these orders provide a solution for the panic man, I can set up proportions. So I can continue to find out how much red paint and blue paint I would need. I'm just going to continue using red to purple and constantly using the 2/5. This time now I'm going to make 35 gallons. The next time I'm going to make 205. Nope, not 105, not 205, excuse me. So 5 times 7 will give me 35, so multiply by 7 here, and so that will be 14. And 35 minus 14 gives me 21. And then this one will be times 21. So 2 times 21 will give me 42. And I get 63 gallons of blue paint. So the solution, again, is to set up a proportion using the information that I have. Number 4 says that the diagram shows a series of squares drawn on a graph paper. The side length and perimeter of each square are labeled. S is side length, B is perimeter. Use the diagram to complete the table, and then write all the ratios in simplest form. This is going to be very simple, I think, to fill out the chart. Obviously, some of you might have gone ahead already and said 1, 2, 3, 4, 5, 6. Now, we don't always want to just go ahead and assume that that's what the numbers are going to be. They could have changed this last one. If they didn't put 24 here, let's say that they put, 30 or something else, they could change our number that we're going to be putting in where the 6 goes. So be careful when you fill these in. So if I was to look at the chart going this way, if the side length is 1 and the perimeter is 4, then notice that the ratio, perimeter to side length, I'm going to put the 4 first and then the 1, and that reduces down to 4 to 1. The second one, they're showing us the perimeter right here is 8, so I know that that will be 8 as well. From my diagram over here, when the side length is 3, then the perimeter is 12. Again, they gave us that information. So if I do 12 thirds, that'll give me 4 firsts. Now if I do 16 fourths, again, that gives me 4 firsts. And I apologize, my handwriting looks terrible. If my side length is 5, 5 times 4 will give me 20, so 20/5 will give me 4 firsts. And let's hopefully make sure that this does reduce down to 4 firsts, and it does. So the last question says, is the relationship between the perimeter and side length of a square proportional? How do you know? Yes. Each ratio is equivalent to 4 firsts. Kids are going to come in the room in 1 second. So thank you for watching. We'll see you tomorrow to work on practice 2-1.